Alright, so in this video, we'll be looking at molarity, and molarity is going to be the most common unit of concentration that you'll come across in whether it be AP chemistry, general chemistry, even on the MCAT. So again, it's very, very common, so it's important that you understand it well. And when I say that, unlike some other things in chemistry, molarity isn't something that is inherently very complex. Molarity, denoted by the letter capital M, can be found simply by dividing moles of your solute by liters of solution. So yeah, I mean, it is straightforward. It looks really straightforward, right? And that's really because it is. It isn't inherently difficult. It's just that when you're dealing with different units like grams, milligrams, liters, milliliters, molarity, molar, all of these different words, all of these different numbers, people often get confused and make mistakes, especially when you're under that time crunch during an exam. So it's just important that you keep everything straight and you don't lose points where you don't have to. And you'll especially see in the coming units of chemistry that molarity is going to be something that you come across a lot. This kind of conversion or being able to go from molarity to grams or to liters, or if you're given like this type of problem that we're given here where you have a certain amount of solute, certain amount of solution, and you have to find the molarity. These are often going to be the first steps in a lot of problems, so it's important that you get these things straight and you're able to be very comfortable doing so. All right, you shouldn't have to be spending too much time thinking about this, especially, during an exam. Okay, like I said, molarity is denoted by this capital M, so this rather straightforward formula. But you should always note, again, this is a place where people tend to mess up inadvertently, is as the numerator is given in moles of solute, you need to make sure that numerator is always moles of solute. What I mean by that is a lot of problems may give you grams of your solute. And you need to remember that you convert using your molar mass to units of moles. Do not get your units mixed up, right? If you took your grams and plugged it into the formula above, you would get the wrong answer. So don't do that. Another very, very common error that I see people doing is not using the right units for the denominator, right? It is supposed to be in liters of solution. In a lot of problems, when you're dealing with smaller volumes, you'll be given your solution in milliliters. Always remember to convert that to liters. Again, not doing so will yield the wrong answer. All right, so now that we kind of got those, cautions out of the way, let me just move on to a general roadmap that if you follow, you will be fine with every molarity question, right? So it's pretty straightforward, as most problems do. You'll be given 1 grams of your solute. Remember how I was just stating, by number 2, dividing this grams of solute by your molar mass, you will get your answer in moles of solute, right? Finally, after that, well, not finally, next, you're going to want to take this moles of solute and divide by liters of solution. You're dividing this number by liters of solution, giving your answer finally as molarity. You're getting the molarity. And remember, this is the same as moles per liter. Okay, I mean, that's something else to keep in mind, actually. I think it's a good thing I brought it up. Is don't, forget the fact that this big letter M is the exact same thing as moles per liter. If you're given or you're told that you have a 3 molar solution, that is the same thing as 3 moles per liter. So it's important that you know this because it's going to be very useful when you're trying to do different conversions, whether you're trying to go from molarity to liters to moles or back and forth. Knowing this is very, very useful. So do not forget the fact that these two are equivalent. Okay, now let's just go through this rather straightforward problem to demonstrate really how straightforward this is if you just get your stuff straight. So we're given that we have a 53.7 gram sample of glycine, which is an amino acid that has the formula C2H5NO2. And this is dissolved in a 495 milliliter of solution, and we have to find the molarity. All right, straightforward enough. So we're given grams. And first, remember, we have to convert that to moles using the molar mass. But in this problem, we're actually not given the molar mass of glycine, and you often won't be given the molar mass in an exam. So you know how to do that, and that should be pretty straightforward to do. So let's just do that now. We have to first find the molar mass of glycine before we can move forward. That is C2H5NO2. How do we do this? Again, just add up the molar masses of the elements that make up the compound. Okay, so 2 times 12.01 grams per mole plus 5 times 1.008 grams per mole. Let's just do this over here. Plus 1 times about 14.01 grams per mole. That's for nitrogen. And finally for oxygen, just add the molar mass, giving us an answer of about 75.07 grams per mole. This is going to be our molar mass of glycine. Right, now that we got the molar mass, let's just get rid of this work. And we can just move on to converting our 53.7 grams of glycine saying we have 75.07 grams 1 mole. Canceling our units of grams gives us an answer of 0. Well, let me just do this over here. We have some space. 0.715 moles of glycine. Now, next step, we're given that we have 495 milliliters of solution. Remember, we have to have this to be in liters. Always, always, always in liters. So, when we're dealing with molarity at the very least, right? 495 milliliters, we know that we have 1,000 milliliters per 1 liter. Canceling our units of milliliters gives us 0.495 liters. Now, the very last thing, we find out that our molarity is going to be just dividing these two numbers, 0.715 moles, divided by 0.495 liters, giving us an answer of 1.44 moles per liter, or we can write it like this as well. So we find that we have a 1.44 molar solution. Okay, that is just about it for this problem. Pretty straightforward. I'm just going to kind of close by saying again, do not forget to, or rather not do not forget, keep in mind the very common mistakes of 1, not converting from grams to moles, and 2, not converting from milliliters to liters. Keep these in mind. Do not be the people who mess up or lose points on something like this. And I guess before I kind of end here, let's just look at one last example problem. Nothing too difficult. Again, it's just getting an idea of how to go from unit to unit. So let's just say in this problem that we have 175 milligrams of sodium nitrate, for example. That's NaNO3, which is going to be dissolved in a 15 milliliter solution. So what we have to find is the molarity. What is the molarity? All right. Okay. And we're given, let's just say that the molar mass, I don't want to have to calculate it here again, and we're given the molar mass already in this problem, is going to be 85, right? Grams per mole. This is our molar mass of sodium nitrate. How do we go about this? Well, we see that our molar mass is given in units of grams per mole, which means we cannot directly utilize this to convert our solute into moles, right? We're seeing that our solute is given in milligrams. So first, this is kind of pulling out a roadmap. We're going to have to go from milligrams to grams and then to moles using this molar mass. Then we're going to have to divide by, well, we can't actually divide first, right? We're going to have to actually first go from milliliters to liters, and then we're going to divide, I guess. I don't know what I'm drawing here. It's moles by liters. Okay, that's just pretty, pretty straightforward then. Okay, let's just do it. So we see that we have 175 milligrams. Okay. How do we go to grams? Well, we know that we have 1,000 milligrams in 1 gram, telling us that we get 0.175 grams of our sodium nitrate. Okay, cool. Now, you take this 0.175 grams, divide by our molar mass, which then will tell us that we have about 0.00206 moles of sodium nitrate. And just notice that I am labeling every place that I can, just so we don't get confused. We're dealing with a lot of numbers here and a lot of units. It's important that we realize what unit or which number is in what unit and what is what. Okay, I just kind of noted these numbers down in my mind. I'm just going to clear this up just for purpose of giving us some more space. Now, we have our moles of NaNO3 to be 0.00206. Okay, now we can just get the denominator of that formula, which is going to be taking our milliliters to liters. Fair enough. So, we have 15 milliliters. We know that there's 1,000 milliliters in 1 liter, giving us 0.015 liters. Okay, now, just the very last step, putting it all together. We take our 0.00206 moles of NaNO3 divided by 0.015 liters, giving us an answer of 0.137 moles per liter, or 0.137 molar solution. Okay, always just keep track of your zeros. Make sure you're not adding too many or too little. That's another, unfortunate or unnecessary, inadvertent way to lose points. So that kind of brings us to the end of the video. I hope you got some value out of this. If it was helpful, please show your support by, liking, subscribing, and, leave in the comments what you guys would like to see next. Thanks again for watching. I'll see you in the next one.